In this first video on chapter 1, we're going to start with 1.1 and just go through some things. I'll touch on a few things in the book and then we'll work in the workbook. So there are some definitions here that you'll want to read through. Organizing and summarizing data is descriptive statistics. That's what we start with. And we're going to work mostly with that throughout this course. The formal methods are called inferential statistics, and when we can use probability to determine that our conclusions are correct or not. So you'll see that later on. We'll touch on it. We won't get in real depth. But probability and statistics go very hand in hand. We'll be working specifically on a probability unit. And then there's some key terms I want to point out here, and I'll go through the workbook with these as well. But population, that's the whole collection. Sample is we're just pulling some random samples from the population that we're looking at, because generally we can't find all the data for everybody in the population. Sometimes we can, sometimes there's census information and things too. So we'll look at how to talk about these things and characterize them. So statistics go with just the sample, like the percentage or things like that from the sample of the population. A parameter we would talk about in relation to the entire population. Variables, we have our independent and dependent variables. We'll talk more about that later. We generally also talk about mean and proportion. And average is another word, what you're probably more used to than mean, but it's the same thing. So I just want to look at this first problem here. Example 1.1. You don't need to take notes on this, just kind of listen and think about it, and you can kind of work along with. Determine what the key terms refer to in the following study. We want to know the average or mean amount of money first-year college students spend at ABC College on school supplies that do not include books. We randomly surveyed 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. So it just means 3 of them. One of them spent $150, one spent $200, one spent $225. So what we're trying to look at here are what are the key terms, and I'll remind you what those are. So population, that's the first one. I don't want to click there yet for you to see it. I want you to think about it. Population would be all of them. So just think in your head, wait, that might be. And then what is the sample? The sample. So we have population, sample, parameter. Might want to jot those down. Statistic. What is the variable we're talking about in this problem? And what are we referencing as data? Okay. So if you think about population, we are looking at first-year college students at ABC College. Okay, so the population would be all of them. The sample would be those who we surveyed. Okay, and I'll show this so you can see it all in a moment. The parameter would be the average all the first year students spent from the whole population, excluding books. And the statistic is the average from or mean from just the sample. The variable we're looking at is the amount of money spent by one student, and the data values are the dollar amounts. So again, population is all the students, sample is just those we surveyed. Parameter is the mean or average spent by all the students, which we actually could get that data. We could get data from the entire population on this one, but that would be really intensive. So if we can get a good sample, it's a lot less work. That's the whole point of statistics. The statistic that we're looking at is the average for just the sample. Variable would be the money spent, and the data values are the actual specific. So variable, we're just saying like the general thing, it would be the money spent, and then the data is the actual amounts. So now I'm going to take a look at our workbook here, and the definitions are here for you. There's a little intro you can read through on your own. And we're talking about key terms. We talked about descriptive statistics, are just organizing, summarizing, displaying data, and drawing conclusions as inferential. And I'm going to actually jump down a little further on. So I just want to point out example 1.5 is very similar to what we just did in the book. It just calls it a local college instead, but maybe without looking back at the other one, you can try to do this problem on your own and make sure you have it down and write everything out. So you can go ahead and do that now, or if you already wrote the other one out, that's fine. And I'll just pop the answers in a moment. Okay, so hang on to your answer for that last one, and we'll pop back up here at example 1.1. A popular program boasted remarkable reading achievement called Your Baby Can Read, which promises that with the use of flashcards, DVDs, pop-up books, and some quality time between parent and child, almost any preschooler could learn to read before they even entered kindergarten. Does this mean all parents should buy and use this program? What do you think? Well, I'm going to say probably not, right? Not necessarily. Other factors could be, many things going on, genetics, learning disabilities, all sorts of things could be affecting that. So I'm going to jot that down here for you. And now let's look at these other definitions. Probability is a mathematical tool used to study randomness. It deals with the chance or likelihood of an event occurring. The theory of probability began with the study of games of chance, such as poker. Predictions take the form of probabilities. We'll work a lot more with probability later on in the course. Do some set theory as well. But here's a couple of examples, ways that we use probabilities. We use it for predictions, like for earthquakes, rain, whether you'll get an A. Another one would be doctors using it to determine the chance of a vaccine causing the disease the vaccination is supposed to prevent. So you probably can think of a couple of others. If you want to jot them down there, that would be a good time to do that. You could just pause the video. And now here are key terms. So just a reminder, population is all the persons, things, objects under study. Parameter is the number that goes along with the population. The sample is a subset of the population. Statistic goes along with sample. Variable is notated by a capital X when we're labeling it, and it's the characteristic of interest for the subject in a population. So here we have example 1.3. Determine whether the given is a parameter or a statistic. List the respective sample or population. Then identify the variable denoted by X. So suppose the percentage of all students on your campus that have a job is 84.9%. So what do you think that is? Take a minute to think about that and jot it down. So is it are we looking at a parameter or are we looking at a statistic? And what is that value? Okay, so it's a parameter because we are looking at all students on the campus as our X. And the value is 84.9%. And the next one, we have a sample of 250 students obtained, and they have 86.4% of them have a job. So jot down what that means, how we would talk about that. Okay, that would be statistic is 86.4%, and the variable is the sample of 250 students surveyed. In this next part, we're going to look at qualitative or categorical variables versus numerical or quantitative variables. So qualitative have qualities just like the name says, or there are categories. There's classified by attributes, characteristics, where numerical or quantitative variables have variables that you could crunch numbers with. It makes sense to take an average of that or something. It's not just for descriptive purposes. So for example, in example 1.4 here, a researcher studied factors that affect the eating habits of adults in their mid-30s. Classify each of the following variables considered in the study as categorical or numerical. So we have nationality, number of children, level of education. So just take a little bit to think about that and what you would put. You could just put like a C for categorical, or cat or something. And then a lot of times we put quant for quantitative. I'll write the words out though. So nationality, that's just describing. So that would be categorical. Number of children is quantitative. You can measure that. Level of education is categorical. Other categorical things like hair color, eye color, things like that. Numerical would be more like temperatures and things like that. So just kind of think about that. Now the next one you can try on your own. Let's pause the video. Okay, so let's see how you did and check your answers. So household income is quant. Zip codes is categorical. Even though they're numbers, they would not be averaged together. That wouldn't make sense to do. They're not even in any, they're not measuring anything. They're really just identifying a location. And F, the intake of whole grains, would be quantitative. Okay, so moving along, we're almost done here. Data, another definition, are just the actual values of the variable. They could be numbers or words. Datum is the single value. So here's that problem again, very similar to the one we did earlier. Really is basically the same problem, but we want to add in if you think it's quantitative or categorical, the type of data that you're getting. And then you can list out the other parts as well, the key terms as well. So here is the population, same thing, all the students in the first year. The sample is the 100 first-year students. Variable is total cost in supplies. The type of variable is quantitative, because we could, average those together. The data are these values, 150, 200, 225. Okay, so that's the end of section 1.1. We'll be looking at 1.2 next. That will be in a separate video. So just remember to go through. It's probably would be a great idea to check out your textbook and kind of, read through a little bit of that, so you have a feel for what's happening. And again, there's these definitions, and you can kind of add your own little notes in to help you remember things, but we'll be going through the examples as well. Right, have a great day.